Okay guys, we will continue this part now. Here ionization enthalpy, you know the definitions and how we calculate the ionization enthalpy and how much energy is required for each ionization enthalpy. You guys came to know about that one. And next we will move on to the ionization trend along the period and down the group in your periodic table. Okay, variation of this ionization enthalpy along the period and down the group. Okay, and one thing guys, your ionization enthalpy variations. Okay, this is what a 3 marks question for your board exam. Define ionization enthalpy and discuss the variations of ionization enthalpy along the period and down the group. Okay, if you write these sentences means you will get easily on 3 marks. Ionization enthalpy definition and variations. Okay, here the variations, first if you consider and along the period means along the period ionization enthalpy increases. Okay, here along the period ionization enthalpy increases. Okay, whereas down the group ionization enthalpy decreases. Down the group ionization enthalpy decreases. Okay, did you got this now guys? Here ionization enthalpy definition and variations. If you write these two sentences without definition means you got 3 marks. Okay, ionization enthalpy definitions, variations is what? Along the period increases, down the group decreases. Okay, here what is our concept of ionization enthalpy? Here we need an energy to be required for an removal of outermost electron from a neutral gaseous atom. That is what our ionization enthalpy concept. Okay, along the period it is increasing out and down the group it is decreasing out. How it will be possible? How come it will be possible? That is what we have to discuss now. Okay, here guys, before going to the discussions, I want to discuss few of the concepts with you guys. First one is what you guys to analyze this concept. Here you should know the two major things. One is what? The first major thing is what? The attractive force between your electrons and the nucleus. Okay, the first concept is what? You guys have to know the attractive force between the electron and the nucleus. And the second concept is what? The repulsions between the electrons in an atom. Okay, electrons in an atom. Okay, these were the two major concepts you guys should know before going to the discussion of this variations of ionization enthalpy along the period and down the group. Okay, here guys, attractive force of electron and the nucleus. You know that yes, here nucleus and electrons were there in an atom. And you also know that nucleus will consist of a positively charged proton, and this positively charged protons we consider this as what? Effective nuclear charge, right? If effective nuclear charge is more, observe carefully what I am telling. Observe carefully guys here. If effective nuclear charge is more, if E and C effective nuclear charge is more, then attractive force between your nucleus and the electrons will be more. Okay, attractive force between your nucleus and an electrons will be more. If effective nuclear charge is less, then attractive force between the nucleus and the outermost electrons will be less. Okay, na? Here effective nuclear charge is more, attractive force between your nucleus and electrons will be more. Effective nuclear charge is less, then attractive force between your electron and the nucleus will be less. Okay, here guys, the variation, if you come to an variations, and here the repulsions of electrons in an atom, you know that here the repulsion, why the repulsion will take place in an atom? Because your atom is there means that consists of what? Positively charged nucleus and negatively charged electrons were there in an atom, right? Negatively charged electrons, and all these electrons were negatively charged. All charge. And you guys knows that if light poles were there means that will always repel each other, right? Light poles are there, that will always repel each other. When unlike poles are there, that will always attract each other, right? Here electrons were having an like poles, that means all the electrons will have a negative charge. Like poles always repel each other, whereas unlike poles, that means if positive and negative charges were there, then this becomes what? And unlike poles, these will always attract each other. That means what? Your positively charged nucleus and your electrons will always attract each other, whereas the electron and electrons will always repel each other, and a proton and proton will always repel each other. Be careful with this. Effective nuclear charge increases, attractive force between your nucleus and outermost electrons will increases. Effective nuclear charge decreases, and then attractive force between your outermost electrons and the nucleus decreases. Okay, these things will affect on your variations of ionization enthalpy along the period and down the group. Okay, be careful. And the last, finally, we will get a complete conclusions of all these variations. Okay, here the next thing is what that the repulsions. That means what? Because of the electrons were negatively charged, they will repel each other. Whereas attractive force means what? Positively charged nucleus and an electrons. Because of the unlike poles, they will attract each other. Okay. One thing guys here, effective nuclear charge will hold some electrons in the orbit. Right? Here atom is there means this is what a nucleus. Here there were inner orbitals. These were what? Inner orbitals. Here also electrons were there. Inner orbitals also consists of electrons. Okay. Here this complete electrons, these all complete electrons were holded by your nucleus. Okay. This is what has got an effective nuclear charge capacity of your nucleus. Okay. Because it consists of positively charged protons, and here the electrons were there, those were negatively charged. Then there will be an attractive force which generated between these electrons and the nucleus that will hold all these electrons in an atom. Okay. So that if effective nuclear charge of your nucleus will increase, it means attractive force between electron and the nucleus will increases. Okay. Here guys, one thing you should observe here. For example, I will consider a lithium atom. Okay. You know that the lithium atom atomic number is 3. That means it will have 3 protons and it will have 3 electrons, right? It will have 3 protons and it will have 3 electrons. And what is an electronic configuration for your lithium? You guys know that 1s2 and 2s1. That means in 1s orbital we are having 2 electrons, whereas in 2s orbital we are having 1 electrons. Okay. If I draw the lithium atom here, means here this is what your lithium atom nucleus, and this is 1s orbital and this is 2s orbital. Okay, 2s orbital and 1s orbital. And you guys, from the electronic configurations, you know that in an 1s orbital there were 2 electrons, 1 electron and second electron. In second and 2s orbital it consists of 1 electron, right? Here according to the configuration, 1s orbital will have 2 electrons and 2s orbital will have 1 electrons. And one thing guys you should know here the proton were 3 in number. That means in your nucleus there were 3 positive charge. Okay. Then this positive charge will experience its power on all these electrons. Be careful, hear carefully, listen carefully here. This 3 positive charged nucleus, this effect of these positive charges will be experienced by all these 3 electrons which surrounds this nucleus. Okay, did you got this? The positively charged nucleus will experience some force of attraction on all these 3 electrons. Okay, but but the force of attraction for your 2s electron, the force of attraction experienced by your 2s electron is somewhat less compared to your 1s electron. There were again two reasons. The reason number one is what? Because your 1s electrons were near to your positively charged nucleus, so that the positive charge experienced by these 1s electrons will be more. Because of these 1s orbitals and 1s electrons were near to your positively charged nucleus, so these will experience more amount of positive charge. That means and more amount of attractive force. Okay. And the second thing is what? Here this positive charge and your 2s electrons is somewhat far away from your 1s. So here this will experience some less attractive force. That is what is first reason. When it comes to your second reason, you guys should know this very important concept, the screening effect, or it is called as shielding effect. Okay, both are one and the same, screening effect or shielding effect. Okay, here guys, in your lithium, these 1s2 electrons were inner electrons and the 2s electrons were what? Outer electron. 2s electron is outer electron and 1s electrons were inner electrons. Okay, this effective nuclear charge experienced by 2s electron is less because of shielding effect and or screening effect. Okay, shielding effect or screening effect. Sir, then what do you mean by this shielding effect or screening effect? That is what the next question running in your mind. Okay, here I will come to this one now. Here shielding effect or screening effect is nothing but what? The positively charged nucleus were near to 1s orbital, and these 1s orbital electrons will act as a screen for the attractive force development between your nucleus and an 2s electron. Okay, did you got this? Here 1s electrons will be an inner electrons or an inner core electrons. These electrons will act as a screen for the development of attraction force between your positively charged nucleus and an 2s electrons. Because of this effect of screening or an shielding of an attractive force of nucleus within your 2s electron, this effect is more here because of this 1s electrons were acting as a screen for the development of the positive charged attractive force with the negatively charged 2s electrons. So that the net charge experienced by your 2s electrons will be less compared to 1s. Okay, first reason is what? Your 1s orbital electrons were near to nucleus, positively charged nucleus, so that they will experience a more amount of effective nuclear charge, or simply you can call it as a charge. Whereas the second reason is what? And shielding effect or screening effect. This is very important concept here, and this will come in first PU, second PU, as well as in your entrance. Okay, here guys, look at this complete explanation. Because these 1s2 electrons will be an inner electrons, these electrons will act as some screen. This will act as some screen for the development of the attractive force between your positively charged nucleus and an electron, so that the net charge experienced by these 2s electrons will be less because of the screening effect made by your 1s electron. Because of screening effect made by your 1s electron, so your 2s electrons will experience less effective nuclear charge. Okay. This is what a simple concept, and next we will move on to our variations of ionization enthalpy along the period and down the road, and there these concepts will come. So I explained these concepts before starting the variation.